Okay, so we're gonna try to see if we can move through this quickly. We have 4 problems. 2 of them are review, and 2 of them are new. So I want to see how quickly we can move through the 2 new ones, or I'm sorry, the 2 review ones, to see how well you truly understand this. Okay, so if I look like I'm going fast, you could say I didn't catch that. I need to see where your level of understanding is, though. My good friend Emma, do you guys know who Emma is? So, oh, you don't. Emma brings treats a lot. She's 0 and 3rd hour. Okay, I'll have you meet her sometime. She's got the face. So anyway, she tried a couple of the more difficult problems, and she sees this. She sees that a lot of the setup, okay, drawing the picture and whatnot, you can do, and you can get the right derivative, but choosing the right formula or knowing exactly that little trick that happens in box 2 is kind of the issue. So that's why I want to go through these 2 so you can see the couple little tricks. And then the back side, those are 2 new tricks. Those are 2 new tricks that you've not seen before. So we'll kind of see how that works. Okay. So here we go. You don't have to make the 4 boxes. I make the 4 boxes simply for my organization, because I lack organization, and this is something that helps keep me on track. So volume of soccer ball is increasing. I draw the soccer ball. I'll draw a sphere. We know it's getting bigger. In fact, we know this. Well, no, you guys got to start doing the problems. What's the formula for volume of a soccer ball? Very good. What else should I write down in that box? Good. V prime is 6. What else? We're trying to find D prime. Somebody else make a statement here then? What's... Very good. I don't know what the radius is. Okay, I'm not trying to solve for the derivative of the radius. What I'm trying to solve for is D prime, so I have to make a substitution. The radius is equal to 1/2 of D. So now what? So now I have a new formula. Now, I want you guys to be careful here, because here's what happens. If you leave it like this and take the derivative, you would have to use the chain rule, because you have a function inside a function. You don't want that. So just multiply it out so you kind of have your monomial term out here, that kind of polynomial shape. So we get volume is equal to, what's 1/2 to the 3rd? Times 4/3. Now 1/6, 1/8. 1/8 times 4/3. What's 4 over 24? So we got pi over 6 times d to the 3rd. That's our formula for volume in terms of d for this problem. How many variables do we have? We got 2. We can take the derivative of volume because we know what volume is, and we're just then solving for one variable, which is d prime. So I'm fine to take the derivative here. We're taking the derivative with respect to what variable? Time. Is there a t in any of these equations? Therefore, we have to, remember that implicit differentiation type piece. We take the derivative of volume equals pi over 6 d to the 3rd, and you get v prime is equal to pi over 2. Very good. D squared d prime. Excellent. V prime is pi over 2. Do you know d? I don't know the current diameter. How can I figure that out? Go back to the original problem. I know these 2 pieces. I know volume is equal to 180, and I know volume is equal to pi over 6 d to the 3rd. Therefore, I solve for d. 180 equals pi over 6 d to the third. If you solve for that, I believe you get 7. So, I can now plug that in. What is 7 squared? 49 times d prime. So now I'll divide both sides by pi over 2 and divide by 49. If you divide by pi over 2, realize you have to put it in parentheses. If you want to leave it in pi, that's fine. I'll express both answers for you guys. Yep. I have 0.078. And what is our label? So that one involves the substitution. Okay, substitution for D. That's what made, or substitution for R. That's what made the problem a little bit more difficult. Why is it just centimeters, not centimeters squared or centimeters cubed? We could try the decimal again. Okay, I was gonna say I did it twice. So, all right, we got it. Super. All right, got it. Okay, let's try one a little bit more difficult. This is another review problem. What's that? What's the answer if you leave it with pi? 12 over 49 pi. Paper cup has the shape of a cone, so you got to be able to visualize this. With a height of 12 centimeters, radius of 4 at the top, the water is poured in the cup at a rate of 2 cubic centimeters per second. How fast is the water level rising when the water is poured 5 centimeters deep? What kind of shape should I make? Very good. Cone that looks like this. And I know an important relationship, namely that 12 is the height of this cone, this glass that I'm pouring into. And I know that the radius is 4. I'll draw that right there. You tell me what should I write in the second box. Formula for a cone, okay, volume is equal to 1/3 pi r squared h. Good. V prime is 2. What else? H equals 5. What else? Okay, you guys can't get too confused here. We'll watch what's happening, okay? Here you go. This is a cup. You got a water level. All right, so you got 2 different heights. You got the height of the cone as it has its shape, then you got the height of the water. Is the cone changing? Is the height of the water changing? Yes. So we're looking at height of the water. That's our H that we're representing. We know that that is 5 right now. Okay, so Larry's doing something that is a good idea, but ultimately will end to failure. So, right. Okay, so you see it that you can end up finding the current radius, can you not? Here's the problem. Watch. If you take the derivative of this, what rule do you have to use? The product rule. If I use the product rule, true or false, I'll come up with both an R prime and an H prime. True. We're trying to solve for H prime, right? Do you have an R prime at all? So even though we know the current R value, we don't know the current rate at which the radius is changing. So because we don't know that, we would end up with 2 variables that cannot, we couldn't solve for one then. Do you see that conundrum? So it's interesting Larry says that because 2 years ago when I did this problem for the first time again, as I hadn't done them for a while, I did the same exact thing. I took the derivative of this, And I was like, oh, well, I could go ahead. I'll use the product rule here, and I'll figure out what this radius is right now. And ultimately, I didn't get it correct. Okay, because I ran into that problem. I was like, well, how do I find r prime? And I was trying to think through it. I was like, wait a minute. I've got similar triangles, as Emma says. Because we have these similar triangles, we are going to set up a proportion, namely the radius over the height. The radius over the height always stays at a constant proportion. What is it? 4/12. Cross multiply, we get 12r is equal to 4h. Divide both sides by 12, and you find out that the radius is always 1/3 of the height. So that's a very important part that we need to use. Because now I can write the formula for the volume of this particular cone in terms of just what variable? H. And because we're looking for H prime, that's what we don't know, that's the key, that's what I want to solve for. So Megan asked a good question the other day. She asked, exactly, how do I know which variable I'm solving for? In the context of the problem, how fast is the water level rising? That means we're looking for the H prime. That's really going to, drive your problem. That's going to really shape it for you. If it asks how fast the radius is changing, well, then instead of solving for r, we would have solved for h, and we would have changed the problem. Okay? But it's not asking for the radius, it's asking for the height. So I can now take this 1/3 h, and I can plug it in right here and get rid of my r. So the volume is equal to 1/3 pi times 1/3 h quantity squared times h. What's 1/3 h squared? 1/9. And what's 1/9 times 1/3? So we end up with volume is equal to pi over 27 times h to the third. Now I have a nice formula. Again, this is a related rates problem, which means that the volume is changing, the height is changing, the radius is changing, and they're all changing with respect to time. So I take the derivative with respect to time, which means because I don't have a t variable in there, I have to use our implicit differentiation idea the entire time. So volume equals pi over 27 times h to the third. What's the derivative of volume? Very good. Pi over 9, h squared, h prime. Very good. And now in the last box, I go ahead and solve. What is v prime? Dos! Spanish for 2. H squared is 25 times h prime. So we want to solve for that. I'm sure you come up with the same answer. I got 0.23 centimeters per second, or 18 over 25 pi, if you'd prefer to leave it in that form. Yeah, that's fine. Everybody good? Yes, it is a derivative, it is a rate, so we must label it. Super important. That was kind of a review problem as well, right? But you see the trick. In both these problems, we had a substitution piece, did we not? And so you have to understand if that's what you have to do. Let's see 2 new problems on the backside. So we moved through those pretty quickly, but you guys were able to get through the first 6 yesterday. You said you felt confident about those. So the 4 boxes make sense to you, yes? Okay, let's try 2 problems that are a little bit more challenging. They're really nice. They work out pretty cool. But, so So let's go to something that's unfamiliar to you, this problem setup. A man is walking away from a lamppost that is 22 feet tall. Immediately, I draw the lamppost, because I'm an excellent artist. I draw the man. The lamppost is 22 feet tall, it says. He's walking away at a rate of 3 feet per second from the lamppost. So this rate right here is 3 feet per second. The man is 6 feet tall. Put 6 over him. So there's a shadow that extends out in this area, right? Everybody agree? The question is, how fast is the tip of the shadow moving away from the man when the man's 15 feet away from the post? And how fast is it moving away from the post? Oh boy. I'll admit, you guys, when I see these type of problems, I don't always know where to start. You should see one thing here that's going to drive this problem. What do you see? What geometrical relationship? Similar triangles. You got to see that. That's going to be the relationship that will set up. And you know that for similar triangles, sides are proportional, and that will drive our equation. But here's what I ask myself when I do these problems. Okay, this is really important concept. Is the height of the lamppost changing? No. Is the height of the man changing? No. Is the distance that he is from the lamppost changing? It is. It is currently at 15, but it will become different, won't it? So if it changes, I need to assign it a variable. And so I'm going to assign it the variable d for distance from the lamppost. But it's changing. It is changing. I mean, if we take a snapshot of this in time, everything would have a constant value at that one snapshot, but it is changing. Is the length of the shadow changing? It will change. The further he walks away, the bigger the shadow will get. So we need to assign that a variable. I will call that variable s. So you see, I look for what's moving, what's changing, and what isn't. If it isn't changing, I can keep those numbers. If it is changing, I need to do something about that. So let's look at our triangles and set up a proportion, and then we can assign our knowns and our unknowns. Everybody see the two triangles? Give me a proportion for the big triangle. Anything. 22 over? What? No. D plus S, thank you. Good try. Because it's changing, we have to write it like that. Only after we take the derivative can we put in the 15 if we need to. Actually, we don't even need to. Okay, so you went height of the lamppost over the entire distance. Got it. So then this one's going to be 6 over S. Well, I can tell right now that I've got how many variables? 2. So I should write down S, D, S prime, D prime. Do we know D? It's 15. Do we know D prime? 3. 3 feet per second. What are we trying to find? S prime. S prime. Do we know S? Do we know the current length of the shadow? If we wanted to, could we find it out? Maybe we won't need to. Okay? If we needed to, we could figure it out. Okay? But we don't need to right now. So let's that's our equation. Right now, what rule would you need to use? The quotient. Does that make you angry inside? I agree. Me too. So what should we do? Cross multiply. So I get 6D plus 6S is equal to 22S. Subtract the 6S, I get 6D is equal to 16S. just leave it. That's fine to me. We're taking the derivative with respect to, is d changing? It is. Because it's changing, you have to take the derivative first. Have to take the derivative first. So, I have the derivative of 6d equals 16s. What's the derivative of 6d? 6d prime. What's the derivative of 16s? 16s prime. Look at your derivative result. Does it matter what the current distance is? No. Does it matter what the current shadow length is? No. That does not matter in the problem. We didn't really know that until we took the derivative and saw that it doesn't come up. Does not come into play. So, do we know the current d prime? We do. So we can set this up. 6 times, what is d prime? 3 is equal to 16 times s prime. So we have 18 equals 16 s prime. 18 divided by 16 is 1.125, or 9 over 8. There's 2 questions here, you guys. The first question is, how fast is the tip of shadow moving away from the man? And the second one is, how fast is the tip of shadow moving away from the lamppost? Which one have we answered? Away from the man, because we answered s prime, right? All right? So it's moving at a rate of 1.125 feet per second away from the man. Now, I want you to think about this real quick so you can kind of understand it. Ever gone to the airport and you walk on those fast sidewalks? Okay, let's say that they're moving at 5 miles an hour, okay? And you're walking at 2 miles an hour. How fast are you moving compared to the people who are not on it? 7 miles an hour. How fast would you be moving compared to somebody who's just standing on the moving sidewalk? 2 miles an hour. That's what we have here. That's the 2 miles an hour, and then that would be the 7 miles an hour. So all we need to do is just add that rate to that rate. That's all we need to do. Yep, so 1.125 plus 3 is 4.125. So the 1.125 is the rate at which the shadow is moving away from the man. But because he's moving at a rate of 3 seconds away from the lamppost, the shadow is moving at a rate of 4.125 feet per second away from the lamppost. It's the whole idea of the airport thing, right? Because like right now, what is your speed on the ground relative to this ground right now? 0. Relative to the sun? Oh my gosh. The Earth is moving very quickly around the sun, is it not? So you have speed, but speed relative to the sun. You don't have speed relative to the ground right now. Got it? All right, last problem. You like that setup? Yeah, kind of cool. Let's do the last one. What time do we get out of here? 11:11? Yes! We got time! Let's do it! All right! Area of a triangle is increasing at a rate of 4 inches squared per minute, and the altitude is increasing at a rate of 3 inches per minute. At what rate is the base increasing? When the base is 10 inches and the area is 24. Oh my goodness, what do I do? Draw a triangle. Good. See? You always know where to start, right? Box 1. Yeah, what is an altitude? It's a height perpendicular to the base. So, I'll call it A for altitude. B for base. I drew it. Now what? You lead me through. What do I write down? Okay, I'll do that. A prime equals 3. Since you wrote A prime, I would also like to write this then. Area equals 1/2 times the base times the, well, instead of writing H for height, I'll write A for altitude. How's that? Oh, I'm sorry. I'm sorry. You're absolutely right. We mixed up our A's here. So area of the triangle, A prime is 4, whereas rate of the altitude, A prime is equal to 3. Solveig saw I had written 3 there, so she said little a prime is 3. And I misinterpreted because I got too excited. What else should we write down? B is 10. Do we know? Okay, big A is 24. Do we know little a? And maybe we won't need it. But if we do, could we find it? If we know the base and we know the area, we could find the altitude. What's different about this problem, folks? What are we trying to find here? Yeah, you're trying to find B prime. So look at this. You got 3 primes here. Area prime, base prime, A prime. The difference is in all the other problems, you're just given really one rate of change. You're given, say A prime. And you said, now find B prime. Well, now you're given area prime and altitude prime. So let's think about this. Normally, you'd want to substitute something in, and we don't need to. If I take the derivative right now, what rule would I have to use? Product rule. True or false? If I use the product rule, I'll come up with an A prime and a B prime. True. The A prime I have. The B prime I'm solving for. So let's do it. Let's do the product. I'm going to take the derivative with respect to time of A equals 1/2 B times A. Do you not like that 1/2? I've seen worse. I like that. Thanks. You're so. All right. I'll show you a trick if you don't like the 1/2. 2A equals BA, right? We can still, we're doing implicit differentiation. We can still take the derivative. What's the derivative of 2A? 2A prime. Now when I do the product rule, I don't have that 1/2 there. Sometimes that confuses people. You remember the product rule? B prime A plus A prime B. Very good. So we will have to find A. Let's put this over there. What's 2 times area prime? 8. Do we know B prime? No, we're trying to solve for that. Times A. Do we know the current A value? No. Plus, do we know A prime? What is it? Do we know B? So we got 30. So we need to find this A value here. So I know that area is currently equal to 24, which is 1/2 times, do we know the base? 10, we don't know A. So 24 is equal to 5A, or 4.8 is equal to A. We divide both sides by 5. So 8 is equal to 4.8 D prime plus 30. Now what? Subtract 30. It's been a while since we've done something that easy mathematically, right? All right, so we subtract our 30, we get negative 22 equals 4.8 B prime. Divide by negative 22 divided by 4.8. And we got, what's our measurement? Inches per minute. Very good. Inches per minute. Now, what do you notice about that rate? Negative. What does that mean? What's getting smaller? So what's happening here, this is kind of interesting. The altitude is getting bigger. And the area is getting bigger. But in order for that to happen at the rates that they are, as the altitude is increasing so quickly, that in order for it to help the area increase at its rate, what has to happen is the base has to get smaller. So it's going from a triangle that maybe looks like that to a triangle that looks more like that. The base is getting smaller. At some point, the base can only get so small, right? So you got it. Can you do this stuff? Okay, alright. Here's what I want you to do. Take out your packet from yesterday. Now, Brooke wants that from yesterday, don't you? Yep, I'll read them off. I'll read them off again. Brooke, I know you're going to find this hard to believe. Well, I do. Let me find it after I do this. Okay, here's what I want you guys to do. Okay, on your sheet, I want you to circle numbers 1 through 9. Circle 1 through 9. Okay, circle every one. I want you to box 10 through 16. And I want you to make triangles on 17 through 22. So you really got... So I took the 4 levels, I divided them up into what I thought were kind of 3 sections I thought were probably best. Now, 1 through 9 is non-negotiable. I mean, that's... You got to be able to do 1 through 9, okay? All right? Now, here's what I told you guys yesterday, okay? I told you do the first 6 and then choose 3 from level 2. So if you did, you're fine. You're good to go, okay? You're good to go. Here's the rest of your assignment, okay? Here's the rest of your assignment. What I would like you to be able to do, okay, for tomorrow as you work through, is I would like you to be able to do 6 more related rate problems. So if that means that you choose 6 of the boxes, so that's from the box on. That's not any of the circle ones. That's from the boxes that are triangles. I'd like you to choose 6 more. You have all day tomorrow to work on it. I will have the I'll have the answer key done hopefully, okay? And you can check everything. So I'd like to try 6 more of either the boxes or the triangles. The boxes are 10 through 16 and the triangles are 17 through 22. So if you want to try one of the harder problems on the triangles, they're not impossible, but they might be a little bit more challenging. They're kind of fun. And that's what I've got for you. Okay? All right. So you don't really have much time right now. I'm going to give Brooke her assignment. So long, Cody. Does anybody know where Cody is? Cody, we miss you.